Hi guys, we're picking up again on page 21. We are in 9A, talking about solving quadratics by factoring. So we did these examples up there. I'm going to work example 2A, and I think I'll put 2B on the video chat. But basically, they are asking us to go backwards. If you notice what we did on these four examples up here is we actually found the solutions. And we said we were going to have two solutions because we started out with an equation that had an exponent of 2 for x. So down here, they're giving us the two solutions, and they're asking us to go back the other way and tell us what was our quadratic equation to begin with. So in thinking about how we even looked at this one, we had two factors set equal to 0. And we can actually just kind of back this up in our head, but if you want to do it systematically, we can say, okay, in order to set this equal to 0, I need to add 2 to both sides. So I have x plus 2 equals 0. And to get this guy equal to 0, which is the way we started, then I'm going to subtract 5 from both sides. And we have x minus 5 equals 0. So now going backwards yet another step to get back to these two factors multiplied together, we can say, well, to get x is equal to minus 2 and x is equal to positive 5, these two guys were our factors, and they were equal to 0. Now the next thing we need to do is go ahead and double distribute and get what our original equation was. So you have x times x minus 5. If you don't need to write this down, you don't have to, plus 2 times x minus 5, doing the double distribute. Cleaning it up, we get x squared minus 5x plus 2x minus 10 equals 0. And the final step would be combining our like terms, and we get x squared minus 3x minus 10 equals 0. So here is our original quadratic equation that ended up with these two guys as the solution. So you guys work B as part of the video check, and we'll talk about it in class next time. I want to go on to the next page. And in looking at this, I think I'm going to work example B, and then we'll come back together and work some of these other problems together in class, and I'll give you guys a shot at doing them on your own as well. So these are not entirely different from what we've done before with the park or a swimming pool with a walkway around it, or a garden with a walkway around it. That's what we have here. We've got a pool, a rectangular pool. So here's my pool. Put some water in it. There's my pool. And it's surrounded by a walkway of uniform length. So that means all the way around, even though my picture doesn't look like it's of uniform length, this distance and this distance and this distance and this distance are all the same. So it says the pool measures 12 by 24. So we can go ahead and write that in, 12 by 24. What else do we know? Oh dear. The total area of the pool and the walk. So all together, the total area is 640 square feet. And they want to know how wide is this walk. So if we call this distance x, because we don't know what it is, that's what we're trying to find. And the pool, again, is 12 by 24. You might be able to make your picture a little bit better than mine. So I'm going to start with the area of the entire structure. So the area of the entire structure, of course, is length times width. And they tell us that that is 640. So the entire length, we've got the 24 here, and the x here, and the x here. So that is 2x plus 24. Don't forget your parentheses. You need these grouping symbols. And the width, this guy, is 12 plus x plus x. So he is 2 of those x's plus 12. So now you can see we're going to double distribute. We're going to have to clean this up, collect like terms, and solve. And I'll let you pause the video if you want to do that on your own. I went ahead and did it, so I'm just going to go ahead and save a little bit of time by writing what the distribution is. So it's 4x squared plus 24x plus 48x plus 288. So that's what you get when you double distribute. And now I need to collect those like terms in the middle, the x's. So I'll have 4x squared plus 72x. Somehow I've got to get a negative sign in here. Let's see, where do I go to get that? I know what I was thinking. So we need to end up setting this equal to 0 to solve this quadratic equation. So if I have plus 288 here, the next thing I'm going to do is subtract 640 from both sides. So now I have 0 equals 4x squared plus 72x minus 352. I knew I needed to end up with a negative sign there. Okay, so now I'm on my way. I'm looking for a GCF. Before I actually do the AC method, I'm looking for a GCF, and 4 is the GCF. So you can take a 4 out. I need some more room, so I'm just going to go down here. You can take 4 out, and you end up with x squared plus 18x minus 88. And I can divide both sides by 4 to get rid of that 4 altogether. So now I have 0 equals x squared plus 18x minus 88. This looks a little simpler to factor, and I can use the AC method, and I end up with 0 equaling x plus 22 times x minus 4. And if you want to pause the video and go find your factors, your AC method factors, you'll come to the same conclusion that I did. So now, of course, if we set each one of these equal to 0, you get x is equal to negative 22, and you get x is equal to positive 4. So you go back up, and what are they asking us to find? Oh, yeah, x. How wide is that walkway all around the pool? Well, I come down here, and at first blush, it looks like I have 2 answers, because, of course, I do have 2 answers. But in this particular word problem, this answer doesn't make any sense. This walkway cannot be a negative width. So we throw out that answer, and our answer becomes the only possible choice, the width of the walk. So the width is 4 feet. Okay, so we'll come back and work some more of these together. If you've got questions, I'll be glad to answer them. But you might go ahead and try 3A up above yourself just to see what your questions are. Thanks for watching.